Okay, let's unpack this. Welcome to the deep dive. You've handed us this stack of sources. It's a really interesting mix, actually. We've got articles, research notes, news clips. It covers ground from, well, the incredibly small world of chip design all the way up to big questions about privacy and even what happens when you mix biology and silicon. Pretty wild stuff.
It's quite the collection, isn't it? Feels like a real snapshot of where innovation is bubbling up right now. Everything seems to be accelerating, from the basic hardware level to how we're interacting with AI and even, biological systems.
Exactly. And your mission for us here, like always, is to cut through that sheer volume of information. We're going to dig into this material, pull out the most important nuggets, the surprising bits, the core insights, and try to give you that shortcut to being genuinely well-informed on this pretty diverse set of topics. Ready to jump in?
Absolutely. Let's start small.
Small is right. Because when you look at the bleeding edge of hardware, it often comes down to what's happening right there on the silicon wafer, doesn't it? Your sources specifically mention Apple's upcoming A20 chip. Looks like it's heading for devices like the iPhone 18 Pro models and maybe even an iPhone 18 Fold.
That's the one. And it's being built on TSMC's second-generation 2-nanometer process.
2 nanometers. That's already incredibly tiny.
Right. And that usually means, more transistors packed in tighter. More power, better efficiency, the usual story. But the really fascinating piece mentioned in the sources isn't just the size, it's how they're actually putting the components together. It's called wafer-level multi-chip module packaging.
Okay, let's break that down. Wafer-level multi-chip module packaging. Sounds complex. What's the actual insight here for someone thinking about, say, getting the next iPhone?
Well, the key insight is how it changes things, how they make it, and what that means for performance. Traditionally, you'd cut individual chips from the wafer, package them up separately, and then connect them on a circuit board, right?
Yeah, standard process.
So with this wafer-level MCM approach, they're essentially integrating different bits, this CPU, GPU, memory, whatever, directly onto the silicon wafer before they even cut it up.
Huh. So they're assembling the phone's brain while it's still on that main sheet, instead of dicing it first.
Precisely. They connect the individual dies right there on the wafer itself. And the payoff, according to the sources, is pretty significant. You get much better thermal management.
Heat dissipation.
Exactly. Fewer layers for heat to get stuck in.
Right.
And also improved signal integrity, meaning data moves between the components cleaner and faster.
Okay, that makes intuitive sense. Less distance, fewer roadblocks, sort of. And your sources pointed out that this kind of tech, it was previously just for, the really high-end stuff, data centers, AI accelerators.
Which tells you a lot, doesn't it? Technologies that were powering massive AI computations for, Google or OpenAI.
Yeah.
They're now migrating down into the chips inside the phone you might carry. The insight here is that mobile device capabilities are really converging with and borrowing techniques from supercomputing and high-end AI hardware much faster than before. For you, the user, this could mean a noticeable jump in how fast your phone feels, how long the battery lasts under heavy use, and what complex tasks, especially things involving on-device AI, become possible.
That's a powerful trend. Definitely one to watch. Okay, now, from chips you can't see to hardware you definitely can, and maybe want to take outside this summer, the Anker Soundcore Boom 3i speaker.
Oh, yeah.
Your sources threw in some details about this that are just, practical and kind of fun.
Yeah, this one isn't just about the sound specs. It's clearly designed for, real-world use out and about. The most appealing features mentioned are its durability things. Yeah. It's saltwater resistant, which is a step up from just basic waterproofing.
Oh, nice. For the beach.
Exactly. And it actually floats, so dropping it in the pool or, getting hit by a wave isn't game over.
The floating feature alone is huge, saves a lot of panic. And there was something about a self-cleaning feature.
Yes, the Buzz Clean feature. The sources describe it as helping the speaker kind of shake off water and, crucially, sand.
Oh, that's clever.
Anyone who's taken a speaker to the beach knows sand gets everywhere. So a feature that actively helps clear that out. That's genuinely thoughtful design. The insight, I think, is that hardware innovation doesn't always have to be about raw power or specs. Sometimes it's about brilliantly solving those common little annoyances of using gadgets in the real world.
I love that. Innovation in convenience. Speaking of home and real-world tech, your sources mentioned T-Mobile making a big push into home internet with their fiber launch. June 5th, right?
Looks like it. A significant expansion for them beyond mobile and their fixed wireless stuff.
Yeah.
The speeds look competitive, up to 2 Gbps, and the rollout plan seems pretty aggressive, targeting over 500,000 households initially aiming for 15 million by 2030.
That kind of scale could definitely shake up the broadband market, couldn't it? Especially where options are limited. And the pricing model looked interesting too.
It does. $60 a month, and they're offering a 5-year price lock, plus discounts if you're already a T-Mobile customer or use AutoPay. The insight seems to be they're leveraging that mobile customer base and trying to stand out with price stability, which is, let's face it, often a major headache with traditional ISPs where rates jump after the promo period.
Yeah, that price lock is a clear value proposition.
Yeah.
And just a final quick note on hardware strategy from your sources. Meta, apparently prioritizing a lighter headset with a separate processing pack for 2026. And that might push a traditional all-in-one Quest 4 out to maybe 2027.
Yeah, it's another example of companies still really wrestling with the basic design challenges of VR and AR hardware. The insight there is that comfort is still a massive barrier to getting more people to use these things regularly. Offloading the processing weight to a separate unit suggests they think reducing what's actually on your head is more critical right now for user experience than having everything perfectly integrated, even if it adds a bit of complexity with the puck. It shows the whole category is still very much in a discovery phase, design-wise.
Absolutely. From the microscopic to the portable speaker to what's in your home, hardware is definitely not standing still. Okay, let's pivot now to something that sounds less like engineering and more like science fiction, but it's real. Your sources talk about human brain cells on a chip.
This is where things get truly mind-bending, yeah. The sources highlight a company called Cortical Labs and their product, the CL1. It's described as a code-deployable biological computer. It actually fuses human brain cells, real neurons, with a silicon chip.
Wait, human brain cells on a chip? How does that even begin to work based on what the sources say?
Well, the system functions by processing information through these super-fast sub-millisecond electrical feedback loops between the biological neurons and the silicon. The human brain cells are kept alive. They're integrated so they can receive inputs from the silicon, and then they respond via electrical signals. They show adaptation, learning, real-time processing.
So it's not just a computer simulating a brain. It's using biological computation itself.
That's the core idea the sources convey, yes. And the main purpose, right now anyway, is as a research tool. The insight is that this is neuroscientists and biotech researchers a platform like never before. They can directly study how brain cells learn, adapt, process information in this kind of hybrid biological digital environment. It could potentially unlock new understanding of intelligence, neurological conditions, things traditional methods maybe can't get at.
That's incredibly ambitious. And this isn't just a lab concept. Your sources say it's becoming commercially available.
Yes, they plan to start shipping the CL1 in summer 2025. The price point is, well, steep, $35,000 per unit, or a bit less, $20,000 each if you buy them in bulk, like in 30-unit server racks. So it's definitely aimed at high-end research labs and institutions.
Understandable, given how cutting edge it is. And this connects, doesn't it, to another development mentioned, Paradromics, their first human brain-computer interface implant back on May 14th. Sounds like another player in that neural interface space competing with Neuralink.
They are. While Neuralink gets a lot of the headlines, other companies are making progress, maybe more quietly. Paradromics' first implant was actually done on a patient who was already having surgery for epilepsy.
Ah, okay. And the procedure itself, it sounded like it was designed to be pretty minimally disruptive, according to your sources.
That's the key point they highlighted, yeah. The interface was implanted and then taken out again in about 20 minutes, all during the existing surgery. So it demonstrated not only the safety of just putting it in and taking it out, but also that this system could successfully record neural activity from the human brain.
Right.
They're now planning a longer-term clinical trial to really study its safety and how well it performs over time. The insight is that this whole field of direct brain-computer interfaces is moving fast. There are multiple approaches being tested, and they're getting closer to actual clinical uses.
It really feels like we're on the edge of some major breakthroughs, maybe slightly scary ones, in integrating tech directly with our biology. And just for a slightly lighter, but still biotech adjacent, note from your sources, Colossal Labs, the de-extinction people.
Ah, yes. Mammoths and dire wolves.
They plan to release the sounds of dire wolves howling later this year.
That's a fascinating one. It's described as a bioacoustic project. While maybe not as technically profound as, neural interfaces, the insight is kind of cool. Technology is enabling these new ways to engage with extinct life. It sort of blurs the lines between science, history, maybe even art, through reconstruction.
From reconstructed howls to silicon neurons. Yeah, the biotech intersection is certainly producing some interesting stuff. Let's move now to the AI landscape. It just keeps expanding relentlessly, doesn't it? Your sources have several updates here, starting with something maybe immediately useful for researchers. Google's Notebook LM, and now supports public sharing.
This is a practical upgrade. Notebook LM, uses AI to help you summarize and understand documents you feed it. Before, those notebooks were just for you. Now, you can generate a public link.
And what does that public link let other people do with your research collection?
According to the sources, viewers can interact with AI-generated summaries of your source material. They can ask the AI questions about the content you put in there. They could even listen to AI-generated audio overviews. The original documents you uploaded stay read-only, though.
Ah, okay.
The insight is that this turns a personal AI research tool into something more collaborative or educational. Makes it easier to share findings and let others explore the sources interactively.
That's a neat evolution. Now, your sources also get into a more advanced concept that's getting a lot of buzz. AI agents. They offer a helpful definition.
Yes, and defining them is key because AI agent can mean different things to different people. The definition provided gives a pretty clear picture. Think of an AI agent as having a brain, usually a large language model, an LLM, for reasoning and planning. It has memory, both short-term for the conversation context and long-term to remember preferences or past stuff. And critically, it has tools.
Tools.
Yeah, access to external functions or data sources. Things that let it interact with the real world, searching the web, sending an email, controlling other software, that kind of thing.
So they're meant to be more autonomous, capable of doing multi-step tasks on their own.
That's the idea. And for people who want to figure out how to build these, your sources mentioned a free resource.
Right?
They did. Microsoft has put out a free 1-hour course called AI Agents for Beginners. Breaks down the concepts design, adding tools, memory, planning, even multi-agent systems into 10 short lessons. The insight is that the tools and the know-how for building these more complex autonomous AI systems are quickly being made more accessible, democratized, you could say.
Okay, this next bit from your sources, this gets into one of the most interesting and maybe unsettling insights from this whole batch. The anecdote from a dinner party with AI insiders.
Yes. That dinner party conversation, recounted in one source, really hits on some critical points about AI right now and where it might be going. One discussion point was about the potential cost. Like, what would it cost to have a personal chat GPT type thing that can permanently learn about you, your history, your preferences, everything, beyond just the current chat window?
Right, persistent memory.
Yeah. The estimate floated was somewhere in the range of $20 to $100 per month for that kind of deep personal AI.
Puts a potential price tag on it. But the real uh-oh moment from that dinner, the core insight that really jumped out.
It was the realization, yeah, that as these AI models get better language, more convincing, more human-like, it gets harder to tell when they're just making things up, even when they sound super confident. The example given was Claude apparently giving a completely wrong answer to some technical question, but sounding totally plausible while doing it. The chilling insight from the people at that dinner was that LLMs will only get more convincing from here on out, which is great for creative stuff or summaries, but profoundly challenging for figuring out what's actually true and reliable.
That's a crucial point. For anyone using AI daily, trust and verification become absolutely essential. Your sources also touched on the business side of the AI boom, startup funding.
Just a couple of quick examples from the sources. Rosebud, an AI journaling app that positions itself as a personal mentor, raised $6 million. And Thundercode, which uses AI for software testing, got a $9 million seed round. The insight is just that while the big foundation models get the headlines, there's serious money flowing into specific, practical applications of AI, enhancing existing tasks, whether it's personal reflection or enterprise stuff like software development.
And then there's the flip side, a concept your sources called AI washing.
This is the idea that some companies might be using the buzzword AI to, attract investment or maybe justify decisions like cutting costs through automation, but without necessarily having truly novel or even functional AI tech behind it.
Right.
The sources mentioned an anecdote about a company, Builder AI, where tasks supposedly done by AI were actually being done by human workers in India. The insight is simply that the AI label itself carries a lot of weight, sometimes misleading weight, in the current market. You need to be vigilant, but past the hype.
Good reminder to look under the hood. Another interesting concept from the sources was the idea of an AI speed limit. What's that about?
This argument suggests that, progress in AI architecture and raw computing power can be exponential, maybe. But there's a kind of natural speed limit imposed by reality itself. AI systems need real-world interaction, deployment, feedback. They need to learn from failures, edge cases, how real users behave.
So they can only really get better by interacting with the messy, unpredictable real world, and that takes time.
Exactly. You have to deploy the models, wait for people to use them in ways you didn't expect, find the errors, collect that data, retrain. This dependency on real-world feedback loops and user adoption inherently slows things down compared to what you could theoretically do just in a lab. The insight is that AI's advancement isn't purely about compute power. It's also gated by the pace of real-world testing and societal uptake.
That adds a needed dose of reality to some of the more breathless talk about AI acceleration. Any final AI notes from your sources?
Just a couple of quick ones. GitHub is launching something called Copilot Spaces. It lets developer teams feed their internal code and documentation to Copilot, basically making it a shared AI-powered expert on their specific projects.
Useful for teams.
And Anthropic, the company behind Claude, has given its AI family its own blog called Claude Explains. It features AI-generated posts, but importantly, they're reviewed and edited by humans. It's an interesting experiment in AI content creation, but with that necessary human oversight layer, acknowledging that reliability problem we just talked about.
That covers a lot of ground in AI. Let's switch gears now to navigating our digital lives, specifically the really critical topic of privacy, because your sources uncovered something pretty concerning.
They highlight some serious allegations against Meta and Yandex, suggesting they're de-anonymizing Android users' web browsing, essentially bypassing standard protections.
That sounds bad. How is this supposedly happening?
According to the sources, the method involves embedding tracking code into millions of websites. This code is designed to kind of abuse legitimate internet protocols, to send unique identifiers from your browser directly to native apps installed on your phone, specifically the Facebook, Instagram, and Yandex apps.
Whoa, hold on. So a website you visit could be talking directly to the Facebook app on your phone, going around the browser's privacy settings and Android's own security.
That is precisely the exploit described in the sources. It bypasses the core security and privacy layers that the operating system and the browser are supposed to provide. The insight is pretty stark. Sophisticated tracking methods just keep evolving, finding clever, technical ways around existing digital privacy boundaries.
And for you, the listener, what's the defense against this specific technique? Based on your sources, is there anything you can actually do?
On this particular issue, the sources are unusually direct. The only effective protection described against this specific alleged method is to simply refrain from installing the Facebook, Instagram, or Yandex apps on your Android devices.
Wow, that's a significant choice to have to make, but crucial information if this kind of privacy circumvention worries you. Okay, on a slightly different note, related to user control, your sources mentioned TikTok introducing new options for You feed.
Yes, TikTok is adding a managed topics feature. It gives users sliders for different topics, arts, travel, sports, things like that, letting them signal how interested they are.
Does this mean you can finally, completely filter out topics you really dislike?
Not entirely, according to the sources. TikTok says these controls won't eliminate topics completely, but they will influence how often you see them as your interests change. The insight here is maybe that while platforms are starting to offer more granular control over feeds, it's often framed as guidance or influence rather than absolute filtering. It reflects that ongoing tension between personalization driven by data collection and genuine user autonomy.
Okay, we have covered a tremendous amount of ground today. From microscopic hardware and biological interfaces through the ethics of AI, personal digital privacy. Let's wrap up with just a few more interesting odds and ends from your sources. First, a thought on the philosophy of making software. This idea that GUI's graphical user interfaces are often built at least 2.5 times.
Yeah, this idea kind of challenges the common view of software development as being like a linear manufacturing process. If you think of building software like building, say, a car on an assembly line, then things like iterating rapidly, throwing away early versions, running parallel experiments, they all seem inefficient, right? Wasteful.
But the sources argue this is actually essential.
Exactly. The core insight is to shift your thinking. View software creation not as manufacturing something you fully defined beforehand, but as a process of discovery. When you're discovering what the best user interface or the best product should be, then building a quick version to get feedback, trying different approaches at the same time, iterating based on how people actually use it, that isn't waste. It's a necessary part of finding the right solution. That initial build, the feedback, the rebuild, that's part of the 2.5 builds needed for discovery.
Shifting the mindset from manufacturing to discovery, that makes a lot of sense for creative, iterative processes like software. Your sources also highlighted the Apple Design Award winners for 2025. What stood out there?
The observation was that mostly indie developers won this year. The sources noted that Apple seemed to consciously bypass many of the big, high-profile AI applications. Instead, they spotlighted innovation using their own core tools and frameworks, often by smaller, independent developers.
Interesting.
The insight could be that this is Apple sending a signal about the kind of development they particularly value and want to encourage in their ecosystem. Maybe emphasizing creativity and clever use of their platform over just chasing the latest tech buzzword like AI.
An interesting choice, if that's the case. And
Cool.
finally, a pretty striking number related to SpaceX.
Yeah, Elon Musk apparently claimed that SpaceX's revenue will get close to $16 billion in 2025. And he made a really remarkable comparison, that their commercial revenue alone, mostly Starlink and launches, presumably could potentially exceed NASA's entire budget next year.
Wow. That really provides some powerful perspective, doesn't it? On the sheer scale and commercial success of SpaceX's operations. Pitting a private company's commercial income against the budget of a major national space agency, that's significant insight into how the whole landscape of space exploration and business is changing. So we've really taken a wide-ranging deep dive into this material you provided. We've gone from the absolute cutting edge of chip design and the, frankly, bizarre frontier of biological computing through the constantly shifting AI landscape with all its promises and perils. We touched on critical privacy issues and even explored philosophies of creation and the economics of space travel. It's quite a mix.
It really is a snapshot of a world where technological progress is just charging ahead on so many fronts at once. You see innovation pushing boundaries at the smallest scales in hardware and biology. Meanwhile, AI gets more integrated, more powerful, but also throws up these new challenges around trust, reliability, privacy.
And the value of doing a deep dive like this is exactly that, isn't it? Taking this seemingly disparate stack of information and trying to pull out the connections, the core insights, the things that genuinely matter for understanding where things are headed.
Indeed. And reflecting on all of this, especially the incredibly convincing nature of advancing AI, even when it might be completely fabricating information. And considering the sophisticated ways personal data can apparently be tracked and linked, it really leaves you with a fundamental question, doesn't it? Given how quickly AI is getting better at sounding convincing even when it's making things up, and how much personal data tech companies can potentially collect,
Yeah.
how do you decide who and what to trust in your digital life?